So this is question 2. X is uniform in A to B and Y is equal to X squared. So question A, we need to find and draw the fx density function and probability density function, and big fx is a probability distribution function. So for the, since it's uniform, we can see like as a whole. For the density function, since it's uniform, it should be the area is the total area is equal to 1. So the height here is equal to 1 over b minus a. So for the fx, we can easily find in when x belongs to x to b, x belongs to a to b, is equal to fx as equal to 1 over b minus a. And other place, otherwise it's just equal to 0. So other place is just equal to 0. And for the distribution function, so before since x belongs to a to when x belongs to a to b as uniform, so less than a, it should be 0, and between the a and b, it should be x minus a over b minus a, yeah. And the last part is x minus a over b minus a. And after b x is greater than b is gonna equal to 1, since it's already it is the sum of it is 1, and it's gonna continue is equal to 1. So for the question B, so a is equal to, given by the questions, a is equal to -1 and b is equal to 3. We need to find and draw the fy and the density function of y and this distribute function of y, and we need to find the expected value of y. So here, since the a is equal to -1, b is equal to 3, and we know like x belongs to a to b, so it belongs to -2 to 3, and y is equal to x squared, so y is equal to s belong to 0 to 9, and we write down, we put the distribution function here, and we may use it later. So here, so we can see like for the distribution function fy, we know like it's equal to the probability y is less than y, and since y is equal to x squared, and so the probability x squared is less than y. So we can see like this will give us fs equal, so it's xy is equal to square root y, and x2 is equal to negative square root y. So basically we can rewrite the probability x squared is less than y to probability x greater or equal to negative square root y, or less than or equal to square root y. So we transfer the question to the distribution function to this. We transfer this distribution function to this probability function. So since we know like for this part, we can easily write down this distribution function is fx square root y. And for this part is also this part is this one. And since the fx is equal to, it's not, so the fx is here, and we need to plug in to see what's the value of that, so this equation. So we can see it's for the fx, it's since a is equal to -1, and before -1 is all 0, and between the -1 and 3, it's between the -1 and the 3 is x plus 1 over 4, and after that is always equal to 1. And for this equation, we can see here, for this equation, we know like for square root y, it's never gonna equal to the negative value. So basically, it's not for this part. When y is equal to 0 to between 0 and 1. So both sides we need to think about, because it's for this part it's belong to here, so it still has some value we need after we plug in. But for when y is greater than 1 and less than 9, the negative square root y is less than -1. So for this situation, we know like the fx of negative square root 1 is equal to 0. So basically for this part, we only just calculate this part. So we can first calculate when y is greater or equal to 0 and less than 1. So both part has some value after we plug in. So square root of y plugging in this equation here, and we got square root of y plus 1 over 4. And the same thing here. So since plug in the negative square root of y plus 1 over 4, so after that we got the square root y over 2. And also, since we already explained this for the equation, this part is equal to 0, since it's not in the this interval, this, and we know like for this part it's equal to 0, so it's just equal to square root plus 1 over 4. Okay, so we got the function for the fy, the distribution function of y. So it's when it's less than 0, and it's just equal to 0. And for the when it's belong to 0 and 1, and we got it's equal to square root y of 2. And the same thing here, when it's belong to 1 to 9, is equal to square root of y plus 1 over 4. And when it's larger than 9, it's equal to 1. So according to this equation, the distribution function, this function, so we know like when we can draw it. So for this part, when it's greater than 9, it's always equal to 1. And for the first part, it's less than 0, it's just always 0. And for the second part, when it's between 0 and 1, so when it's 1, it's equal to 1 over 2. And we just draw down this way. And for the 1 to 9 part, it's equal to square root of y plus 1. So basically, after the square root of 1 x equal to 1 is 1/2, and start here and to the final value 1. And when we try to find the next step is find the density function. So it's just the derivative of the distribution function. So basically, it's just the derivative of this thing. So basically, for this part, it's just 0. It's not, and also this part, after derivative of y is also equal to 0. So for the other two parts here, the derivative of y we can calculate after calculate is equal to 1/4 times square root y, and 1/8 times square root y. And we can draw this one. So for the y between 0 and 1, so it's when it's close to 0, it's infinity, and when it's close to 1, it's 1/4. And 1 x equal to, so it's the second part. So we can see is 1 y equal to 9. It's the square root of 9 is 3. 3 times 8 is 24, so it's 1/24 here. And it's when it's equal to 1, it's 1/8. So we draw the curve here. That's a picture of the density function. So for the last part, so the expected value of y. Here we can see we just times the value. Yeah, the value and the y value, and the times the density function, which is 1/4 times square root y. So same thing here. Basically, we need to do the integral, and we get it's 1/4 times 2/3 times y to power 3/2 from 0 to 1. And same thing here is 1/8 times this equation from 1 to 9. And after calculation, it's equal to 7/3. Yeah.